Hello everyone, welcome to my YouTube channel Chemistry Quest. This is the 8th lecture on solutions. So, in this video we will be discussing about mole fraction. So, till now we have already discussed mass percentage, volume percentage, mass by volume percentage, parts per million. Now it's mole fraction. So, what is mole fraction? Commonly used symbol for mole fraction is chi. It is represented as x, and subscript used on the right hand side of x denotes the component. Suppose there are two components 1 and 2. It is also known as binary component. If the solution contains two components, it is known as binary solution. So mole fraction of a component is equal to number of moles of the component 1 or 2 upon total number of moles of all the components. So let's see through an example. For example, in a binary mixture, if the number of moles of A and B are Na and Nb respectively, the mole fraction of A will be, that is chi A, is equal to a number of moles of A upon number of moles of A plus number of moles of B. Similarly, if we have to write the mole fraction of B, so it will be chi B, which is equal to number of moles of B upon number of moles of A plus number of moles of B. So this is about the mole fraction of A and B. Let's see some more. For a solution containing I, number of components we have x I is equal to n1 upon n1 plus n2 plus up to ni, which can be written as n1 upon summation of n1. So it can be shown that in a given solution, sum of all the mole fraction is unity. Suppose there are two components 1 and 2. So when we add up the mole fraction of both the components like chi A plus chi B, it will equal to 1. Let's see some more important points about mole fraction. So mole fraction is a very useful in relating some physical properties of solutions, say vapor pressure, with the concentration of the solution, and quite useful in describing the calculations involving gas mixtures. Let's do a numerical based on the mole fraction. So calculation involving the mole fraction. So here is the numerical. Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass. So assume that we have 100 gram of solution. Solution will have 20 gram of ethylene glycol and 80 gram of water. So if you want to calculate moles of C2H6O2, so that will be 20 divided by 62, that is 0.322 moles. Moles of water will be 80 gram divided by 18, which is equal to 4.444 mole. So if you want to calculate the mole fraction of glycol, moles of glycol upon total number of moles of glycol as well as total number of moles of water. So when we divide both the terms, it will be 0.068. And we have already discussed that moles of component A plus moles of component B, if it is a binary solution, the total mole fraction addition will be equal to 1. So if we subtract 0.068 from 1, we get 0.9328. This is the mole fraction of water. So if you like the video, please hit the like button, share with your friends, and subscribe to my YouTube channel. And don't miss to hit the notification bell for upcoming videos. Thank you and have a nice day.